All right, it is time to look at Unit 4, Waves and Tides. Follow along in your study guide, fill in the blanks as I get to each one, and then spend some time with this over and over again as we get closer to that exam so you can do as well as you possibly can on our upcoming final exam. First one, waves are started by disturbances that are called generating forces. It generates the wave. Three common wave generating forces are, the big one is wind, and then also earthquakes and landslides, but those obviously are a lot less common than wind. Wind is the most common generating force for waves. Waves are often the result of wind blowing over the water's surface. Capillary waves, or ripples, are the smallest of the wind-driven waves. So capillary is the word you want there. Blank are evenly spaced waves with smooth, rounded crests and troughs. Swells is what we're looking for there. Please know fetch is the amount of open water that wind is blowing over. The more fetch, the larger the wave is typically going to be. A restoring force is a force that causes the water surface to go back to its undisturbed state. So it was generated by wind. What's going to restore it back to a flat state? The two main restoring forces are surface tension, which plays a little role, and the big one is gravity. That's your blank there. Flipping the page. As the wave energy moves through the water, it moves the water particles themselves go in an orbital motion as the energy moves through the water. The highest point in a wave is called its crest, and the lowest point is the trough. 4.2 now. Look at the first three there yourself. I'm going to move down to where the first blank is there. Refraction is the slowing and bending of waves in shallow water. Bending is your first one there. Diffraction is the spreading of a wave around an obstacle. When a wave hits an obstacle and then moves back in the same direction that it came from, that's reflection. Your next one, longshore drift, is the term we use for moving of sand and sediments down a beach. Your next one, I bet you can figure this one out. Rip currents are areas of rapid seaward flowing water. So it's not going towards the shore, it's heading back out rapidly in a hazardous way. That is a rip current. Be familiar with tsunamis there. They're seismic sea wave that can travel very long distances, and they can cause great damage to coastal areas. Tsunamis carry lots and lots of energy, even though they may not be very big waves. They're not necessarily tall, but they have a lot of energy that comes with them. That's where the destruction comes from. 4.3, tides. And that's your first blank there too. Tides are caused by the gravitational pull of the moon and the sun. Please note that the pull of the moon is stronger because it's so much closer. Spring tide, this is when the sun and the moon are at right angles from each other. This happens at full and new moons. You probably don't need to know that. But you do need to know the gravitational effects. It's actually not right. Yeah, let's fix that. So the sun and the moon are in line with Earth. A spring tide is when the sun and the moon are in line with Earth. So this happens. The moon will be here, sun will be here, Earth is in the middle, and so they're both pulling. Both gravitational forces are pulling at the Earth. So this creates a very large distance between the highest high tide and the lowest low tide. Then you have neap tides. That's when the sun and the moon are at right angles. Got on the wrong line there. And because they're at right angles, so the sun is here, Earth is here, and then the moon would be up here. They're at a right angle from each other, and so they kind of cancel each other out a little bit. The effect is not as much, and so the high tides and low tides are both not nearly as extreme as they are with a spring tide. Note that semi-diurnal tides are when you have 2 high tides and 2 low tides each 24-hour period, which is what we have here in Florida. Tidal range is the difference in water level between high tide and low tide, and the tidal bore is when the leading edge of an incoming tide forms a wave when it meets the current of a river. As the river current comes out and the tide comes in, they meet each other, creating a tidal bore. Let's see. I believe that's it. Let me double check the next page. Yep, next page starts Unit 5. There you go. So that is Unit 4. Come back later for the next one. Peace. If I hit the right button.